The Lockheed Martin F-22 Raptor is an American single-seat, twin-engine, all-weather stealth tactical fighter aircraft developed exclusively for the United States Air Force, USAF. The result of the USAF's Advanced Tactical Fighter (ATF) program, the aircraft was designed primarily as an air superiority fighter, but also has ground attack, electronic warfare, and signal intelligence capabilities. The prime contractor, Lockheed Martin, built most of the F-22's airframe and weapons systems and conducted final assembly, while Boeing provided the wings, aft fuselage, avionics integration, and training systems. The aircraft was variously designated F-22 and F/A-22 before it formally entered service in December 2005 as the F-22A. Despite its protracted development and various operational issues, USAF considers the F-22 a critical component of its tactical air power. The fighter's combination of stealth, aerodynamic performance, and avionics systems enable unprecedented air combat capabilities. As the program moved to full-scale development or engineering and manufacturing development (EMD), the production version had notable differences from the YF-22, despite having a similar configuration. The wing's leading-edge sweep angle was decreased from 48 degrees to 42 degrees, while the vertical stabilizers were shifted rearward and decreased in area by 20%. To improve pilot visibility, the canopy was moved forward 7 inches, 18 centimeters, and the engine intakes moved rearward 14 inches, 36 centimeters. The shapes of the wing and stabilizer trailing edges were refined to improve aerodynamics, strength, and stealth characteristics. Increasing weight during development caused slight reductions in range and maneuver performance. The F-22 cannot be exported under U.S. federal law to protect its stealth technology and classified features. Customers for U.S. fighters are acquiring earlier designs such as the F-15 Eagle and F-16 Fighting Falcon or the newer F-35 Lightning II, which contains technology from the F-22, but was designed to be cheaper, more flexible, and available for export. In September 2006, Congress upheld the ban on foreign F-22 sales. Despite the ban, the 2010 Defense Authorization Bill included provisions requiring the DoD to prepare a report on the costs and feasibility for an F-22 export variant, and another report on the effect of F-22 export sales on U.S. aerospace industry. Throughout the 2000s, the need for F-22s was debated, due to rising costs and the lack of relevant adversaries. In 2006, Comptroller General of the United States David Walker found that the DoD has not demonstrated the need for more investment in the F-22, and further opposition to the program was expressed by Secretary of Defense Donald Rumsfeld, Deputy Secretary of Defense Gordon R. England, and Chairman of U.S. Senate Committee on Armed Services Senators John Warner and John McCain. The F-22 program lost influential supporters in 2008 after the forced resignations of Secretary of the Air Force Michael Wynne and the Chief of Staff of the Air Force General T. Michael Mosley. The F-22 Raptor is a fifth-generation fighter that is considered fourth-generation in stealth aircraft technology by the USAF. It is the first operational aircraft to combine supercruise, supermaneuverability, stealth, and sensor fusion in a single weapons platform. The F-22 has 4 empennage surfaces, retractable tricycle landing gear, and clipped delta wings with reverse trailing. Edge sweep and leading edge extensions running to the upper outboard corner of the inlets. Flight control surfaces include leading edge flaps, flaperons, ailerons, rudders on the canted vertical stabilizers, and all-moving horizontal tails, stabilators. For speed brake function, the ailerons deflect up, flaperons down, and rudders outwards to increase drag. The aircraft's dual Pratt & Whitney F119 PW100 augmented turbofan engines are closely spaced and incorporate pitch-axis thrust vectoring nozzles with a range of plus or minus 20 degrees. Each engine has maximum thrust in the 35,000 lbf, 156 knots class. The F-22's thrust-to-weight ratio at typical combat weight is nearly at unity in maximum military power and 1.25 in full afterburner. Maximum speed without external stores is approximately Mach 1.8 at military power and greater than Mach 2 with afterburners. The aircraft has an integrated avionics system where through sensor fusion, data from the radar, other sensors, and external systems are filtered and combined into a common view, thus enhancing the pilot's situational awareness and reducing workload. Key systems include Sanders/General Electric and /ALR-94 Electronic Warfare System, Lockheed Martin and /AAR-56 Infrared and Ultraviolet Missile Launch Detector, MLD, Westinghouse/Texas Instruments, and /APG-77 Active Electronically Scanned Array, AESA, Radar, and TRW. Communication/Navigation/Identification, CNI, Suite. The MLD uses 6 sensors to provide full spherical infrared coverage. Among the most technically complex equipment on the airplane is the ALR-94 system, a passive radar detector with more than 30 antennas blended into the wings and fuselage for all-round radar warning receiver, RWR, coverage. Its range, 250 plus nmi, exceeds the radar's, and can cue radar emissions to be confined to a narrow beam, down to 2 degrees by 2 degrees in azimuth and elevation to increase stealth. Depending on the detected threat, the defensive systems can prompt the pilot to release countermeasures such as flares or chaff. The ALR-94 can be used as a passive detection system capable of searching targets and providing enough information for a radar lock-on. Tactical communication between F-22s is performed using the Directional Inter/Intraflight Data Link, IFDL. The F-22 has a glass cockpit with all-digital flight instruments. The monochrome head-up display offers a wide field of view and serves as a primary flight instrument. Information is also displayed upon 6-color liquid crystal display, LCD, panels. The primary flight controls are a force-sensitive side stick controller and a pair of throttles. The USAF initially wanted to implement direct voice input, DVI, controls, but this was judged to be too technically risky and was abandoned. The canopy's dimensions are approximately 140 inches long, 45 inches wide, and 27 inches tall, 355 centimeters times 115 centimeters times 69 centimeters, and weighs 360 pounds. The canopy was redesigned after the original design lasted an average of 331 hours, instead of the required 800 hours. The F-22 has 3 internal weapons bays, a large main bay on the bottom of the fuselage, and 2 smaller bays on the sides of the fuselage, aft of the engine intakes. The main bay is split along the centerline, and can accommodate 6 LAU-142/A launchers for beyond visual range missiles, and each side bay has an LAU-141/A launcher for short-range missiles. 4 of the launchers in the main bay can be replaced with 2 bomb racks that can each carry 1,000 pounds 450 kilograms or 4 250 pounds, 110 kilograms, bombs. Carrying armaments internally maintains the aircraft's stealth and minimizes additional drag. Missile launches require the bay doors to be open for less than a second, during which pneumatic or hydraulic arms push missiles clear of the aircraft. This is to reduce vulnerability to detection and to deploy missiles during high-speed flight. The F-22 was designed to be highly difficult to detect and track by radar. Measures to reduce RCS include airframe shaping such as alignment of edges, fixed geometry, serpentine inlets and curved vanes that prevent line of sight of the engine faces and turbines from any exterior view, use of radar-absorbent material, RAM, and attention to detail such as hinges and pilot helmets that could provide a radar return. The F-22 was also designed to have decreased radio emissions, infrared signature, and acoustic signature, as well as reduced visibility to the naked eye. The aircraft's flat thrust vectoring nozzles reduce infrared emissions of the exhaust plume to mitigate the threat of infrared homing, heat-seeking, surface-to-air, or air-to-air missiles. Additional measures to reduce the infrared signature include special topcoat and active cooling of leading edges to manage the heat buildup from supersonic flight. Thanks for watching. Please consider subscribing. Information from Wikipedia.